Very first thing we've got here in where we left off last time with 8.2, they're going to ask you to evaluate functions. Now it says it's linear and quadratic and cubic and all stuff. So it's all the same. It doesn't really matter what it is. It's just you're evaluating functions on this part, and they're basically going to give you two different functions. And they'll tell you that f of x is negative 5x plus 2. G of x is going to be negative 2x to the third minus 3 or something like that. And then they're going to tell you, okay, find f of 7 and then g of 2 or something like that. They'll just pick some random numbers to plug in. And when you're doing these, all you're going to do is basically this, is wherever you have the function, that when you have f of x, if they ask you to find f of 7, easiest thing for me to do when I was doing these was I would just take whatever this part is that they tell you to find and write it right underneath it, so that you know that everywhere you have an x, you're going to take the x out and you're going to replace it with 7. So everywhere you have an x here, take out the x and replace it with 7. We've got negative 5 times 7 plus 2. And with functions, again, you don't worry about what's happening on the left-hand side because that's just the notation part of it. It's negative 5 times 7 for negative 35 plus 2. So that means negative 33. Oh, no, not that. Must be the highlighter. There we go. That would be your final answer you're looking for that part. Okay, and when they give you the G part, that's a totally different equation. Basically, it's a part A and a part B. So the part A answer, you're doing f of 7. For the part B part, you're going to take the same thing over here for g of x now. And in that equation, you can do the same thing that wherever you have x, now you're going to replace it with negative 2. So over here, you would do the same thing, take out this x and replace it with negative 2. Now, here's the thing that they do with this one. Here's where sometimes if you notice what they do, it makes it a little bit easier. When they give you these numbers, they're in parentheses. When you plug these numbers in, oh, too much. Leave it in parentheses. Because sometimes people get a little bit confused about the negatives and where they go and what you do. So I tell people, okay, they give you that number in parentheses. Leave it in parentheses, and everything else that's on this thing has to go on the outside of the parentheses. And once you put everything else on the outside, now you're back to 7th grade math. You're just going to do order of operations. First thing you're going to do is your exponents. So you've got to do negative 2 to the third power. If you do negative 2 to the third power, that should be negative 8. Once you've done your exponents, now you're down to multiplication and division. So you're going to multiply negative 2 times negative 8, which is 16. And once you've done all the multiplication and division, then you can do your subtraction here at the end. 16 minus 3 is 13. And that would be the answer for the part of it when they ask you to do G. So it doesn't matter what they give to you, what they call it linear, cubic, quadratic, doesn't matter. It's still the same thing. You're just going to take out whatever you have for x, and you're going to put this number in its place and then work out that problem. Or if it's G, you take out that number for x, plug it in, and then just work it out. And really, once you plug it in, it's a 7th grade math question because it's just order of operations and just working through that part of it. Okay, from there, they go to word problems. Now, and the word problems is they're not really that bad at all because they ask you, I think we looked at a couple of word problems last time, is they ask you to find the output of a one-step function. Now, they give you some word problem to talk about that a plan is ready is already 54 centimeters tall. It grows 1 centimeter every day or every month or whatever it is, and they want to know what the height is going to be. And they give you a formula. They tell you, all right, it's h of m is going to equal 54 plus m, where you determine the height after every month by plugging in whatever the number is. So they make it some word problem where, again, it's not really the word problem. It's just, here you go. They give you a word problem, but they give you this formula. And then they're going to ask you, what is the height after 30 months? Where, again, you're just going to take this number you got and plug it back in. So your months is 30, so that's your m part of it. So take 30 and plug it back in. And it's, again, it's just a one-step problem, so when you get to it, it's just 54 plus 30. It's 84. So even though it's a word problem, it's about one of the easiest word problems that you can get, because you get one number, you plug it in, you add it, subtract it, multiply it, divide it, whichever one of those four options they give to you, and you've got basically the same thing here. Next part of it, they do it the same way, but this time it's for a two-step function. And for this one, they set up the same way. They give you some word problem, talk about what everything is, but then they give you an equation, or they give you a function. They say, all right, we're going to do c of x is equal to 0.06x plus 1150. They're going to ask you, what is the cost for 50 copies? Okay, but it's the exact same as the other one. You've got one variable that you're plugging into for x. They give you one number, so you take that 50 and you plug it back in for x. So it's 0.06 times 50. And then you're going to add 1150 to that. Yeah, and again, it's just basically just order of operations. Go ahead and do your multiplication first. So do 0.06 times 50. If you do that, that is $3 or just 3. In this case, they're talking about money, so if you want to put $3, you can. Then you're going to add 1150 to it, so that makes it 1450. Okay, so on these, don't worry about the word problems, because they're just that. They always give you that equation or that function, and then they're going to give you some number to go back and plug it back in, and you just plug in that number, and that's all you have to do. Okay, so not really much else to those. Now the last part of section 2 is where they go back to, I think didn't we look at the domain range last time? Maybe briefly. Okay, if we didn't, we'll go ahead and do it again. Thought we had. Seems like this one was right in the middle of something here. Find the domain and range. Still 8.2. Yeah, there's this 8.2 had, I think, 10 objectives in it last time, and we got about half of them, so we're just picking up the back half. This one, you're finding the domain and range of a continuous function. Okay, and I'll do the best I can on this one because it's just going to be a graph. And let's do something like this. They've got it going from here down to here.
Yeah.
That's the one? Okay. All right, so, and again, you'd have the grid lines normally, but this one I'm going to have to go back and tell you what the points are. This point would be at -5, 2. And this point would be at 4, -3. Okay. Here's when you're going through this one. Here's what you're looking for. That when they ask for the domain, x values or y values? Domain was x, right? So when you're talking about your domain, that's your x values. So all you're going to do is you're going to tell me how far to the right and how far to the left on this x-axis can I go. So what's the leftmost point on the x-axis? It's this point right here, right? What's the x value of that point? -5. So you're going to start at -5. Let me see how they want the answers here.
Are you doing it up and down too?
For the range, we'll do the range up and down. So for the domain, we're just going side to side. So you tell me the leftmost point, and you tell me the rightmost point. And when you get to those 2 points, just tell me what the x values are. So for this one, we're going to go from -5, and when you get to the right-hand point, that's 4. -3, tell me the x value there. That's at 4. All right, and when you go for the range, well, that's your y values. And when you talk about the y values, you're going up and down. So what's the highest point on the graph? It's right here, right? And for that one, you only use the y value. So your highest point's at 2. And your lowest point would be down here at -3. So when you write those answers, you still tell me the lowest number first, and then you tell me the highest number after that. So your range would be there, and your domain would be there. All right. Let me. Did they make you graph these?
No, the signs.
Oh, the signs. Okay. All right. Let me give you another one here. I was flipping through some of these. Let me show you one that's a little bit different than that. You've got one that looks something like this, where this is at, I was thinking we'd done these last time. That's okay. -4, -1 was this point. This point is at 1, 4. And let's say this thing is going to bottom out at, let's say this was like at 5, -1. Or sorry, -1, -5. So, and on that one, they don't actually put the point, but it's they'll make it really obvious where you can tell that this thing bottoms out. Mine, maybe not so much, but let's just say this bottoms out here. So when you talk about domain, again, what's the left-hand point on the graph? What's the farthest left you can go? Right here, right? And that x value is at -4. So now it's a solid circle. So you got to box it in. It's -4. Okay. Then go to the right-hand side. The farthest right on the graph is over here. That's at 1. And that one's an open circle. So you can put a parentheses on it. All right, for the range. Now we're going up and down. What's the lowest point on the graph? Right here, right? that's this now. And for the range, you're talking about the y value, so now you're telling me this point. That's at -5. And if they give you one like this where they don't actually give you a circle, then basically everything along this line is like a bunch of solid circles. So it's like solid circle, solid circle. Just this thing is made up of solid circles. So if you get to this point, that's a solid circle at -5. Okay, what's the highest point on the graph? This one, right? And that's a 4. So you can go 4 there, parentheses there. So when you're going for your domain, you need the left-hand value, you need the right-hand value. And when you're doing the range, you need the low value, and you need the high value. And again, domain, you only talk about the x values. The range, you only tell me about the y values. So that's what they're talking about when they go through this thing. So just think left and right, give me the x values. Then look up and down, and give me the y values. Okay. The last few things, they're still evaluating a function. I'll give you a couple of those because I think they're all basically the same thing. The only thing they change on the last few parts here in 8.2 is they ask you to evaluate a rational function. And again, with a rational function, that just means it's a fraction. But you're still going to do the same thing with it. You're just going to take the number you have, plug it back in, and see what you get. Okay, so there's your fraction, and then they'll tell you, all right, here's the one number we want you to do to plug this thing in. So again, when you have f of 2, that means everywhere you've got x, you're going to take out the x and replace it with a 2. And because that 2 is in parentheses, when you plug it in, leave it in the parentheses. Okay, and again, you don't do anything with the left-hand side because that's just the notation. You're just working on the right-hand side. 4 times 2 is 8. 4 times 2 is 8. And the top part, you're good there. Bottom part, you just got to do 8 minus 11. So that's -3. So there you go. That's just 8 over -3. Now here's the second one. That was the top one. Nothing really tricky on that one. Just plug it in, go with it. For the top 2 part, they do make you go a little bit farther on this one. Because it does get a little bit more complicated. You've got x squared minus 12x plus 32, and that's over x plus 4. They gave you the option on the first one, so it is a possibility. Even on this first one back up here, it's still a possibility, but probably not on that one. This one, there's a good chance you may get this one to pop in there. Okay, now the good thing is on this one is it's still the exact same problem, that everywhere you have x, you're going to take out that x and you're going to replace it with 6. The only thing that happens is that on the bottom, if you do happen to get 0, it would make it undefined or no solution for that part of it. Okay, so we're going to plug in 6, 6, and then 6. And everything else that's with that problem, it all goes on the outside of it. So you're going to do 6 squared minus 12 times 6 plus 32. On the bottom, you've got 6 plus 4. And again, I can't stress this enough that if you put the parentheses around it, that usually makes everything else a little bit easier, because then you don't have to worry about, because sometimes people say, well, if I've got a negative here, well, when you plug the 6 in, that negative's got to go on the outside of it. And then you're still going to do your exponents first, because technically that would be -1 times that number. That after you do the exponents, then you'd have to go back and multiply it by the negative. But for that one, we didn't put that in there, so let's just take that back out. Okay, so from there, just work it out. 6 squared is 36. And that's the only exponent, so I would say go ahead and do the multiplication next, so you can just do 2 steps at one time. 12 times 6 is 72. So on the bottom, there's really nothing else. You've got 6 plus 4, so that would be 10. And on the top, just go ahead and add and subtract all those numbers. 36 minus 72 is -36. Plus 32 would make that -4 over 10. And when you simplify that, that would be -2/5. Okay. And again, the only thing that could possibly happen on those is that if you do happen to get 0 on the bottom, if you plug all this in and you get 14 or 41 over 0, if you do get 0 on the bottom, that's where it becomes undefined or no solution. Anything else, you're okay. But if you happen to get something over 0 when you work all this other stuff out, that's just an undefined problem. Okay, and then the last thing they do in section 2 is the domain of a rational function. And with this one, they ask you to name the excluded values. And I'm thinking, didn't we talk about this one a while back? Maybe? Or am I getting this confused with something else? Okay. For this one, here's all you do. It's just one thing. You set your denominator equal to 0. Solve that. Whatever you get, that's your excluded values. The numerator, as far as when we talk about what the excluded values are, doesn't have anything at all to do with the denominator. It's just what you've got in the numerator. So if you get x squared minus 2x minus 63 over x squared minus 18x plus 81. Yeah, you don't even care about what the top is. That top part of it doesn't really have anything to do with excluded values. The only thing that's excluded values is just take that part and set it equal to 0. And for these, because you're starting off with x squared, that means you've got to factor them. So you're finding the factors of 81 that would get you 18. If you check it real quick, that'd be 9 times 9, because 9 times 9 is 81. When you add 99, it's 18. Because that's negative, in that case, they're both going to wind up being negative. And for that particular problem, when you solve it, you get the same answer twice. So you don't have to write the answer twice. You can just write it once because it just repeats itself. So for that one, it's just x equals 9. Okay, so all that is just going back to factoring. Take the denominator, set it equal to 0 to factor it. And that's out of 8.2. There's one thing in 8.3. Let's see if there's anything different on it. And, oh, this was I thought we had done this. Maybe we didn't. Where you had to figure out if it was a linear equation or not. And we said if it was linear, it was more of what it could be. You cannot have x times y. You cannot have x to a power or y to a power. That's greater than 1. And you cannot have x or y in the denominator. Anything else, you're okay. If any one of those three things pops up, it's not a function, or it's not linear when you're going through that. And they'll just give you a list of questions and say, okay, here you go. Is this thing linear or not? And you just look at it. If you have x times y, it's not. If you have x or y with a power greater than 1, if you have x squared or y squared or x to the third or y to the fourth, it's not. And if you have x or y in the denominator, it's not. If it doesn't fit one of those three things, it's good to go.